DNS Tunneling Fundamentals. IP addresses, not human-readable names, are used to route Internet data. Whenever we want to access a domain by its domain name, we need to first obtain its IP address. To retrieve or resolve the IP address of a human-readable address, we need to ask various DNS servers. In our lab network, with multi-server 3 as the DNS server, a request from pgdatabase1 for the IP address of example.com would follow the flow shown here. The firewalls have been removed from this diagram for simplicity. Let's try out a new scenario in the lab, which is configured precisely for this purpose. In this scenario, we have a new server, Feline Authority. This server is situated on the WAN alongside our Kali machine. This means that multi-server 3, Confluence 1, and our Kali machine can route to it, but pgdatabase 1 and HR shares cannot. Feline Authority is registered within this network as the authoritative name server for the feline.corp zone. We will use it to observe how DNS packets reach an authoritative name server. In particular, we will watch DNS packets being exchanged between pgdatabase 1 and Feline Authority. While pgdatabase 1 cannot connect directly to Feline Authority, it can connect to multi-server 3. Multi-server 3 is also configured as the DNS resolver server for pgdatabase 1. In order to see how DNS requests will be relayed to Feline Authority from pgdatabase 1, we need to initiate DNS requests from pgdatabase 1 and monitor what comes in to Feline Authority. For that reason, we need a shell on each of these machines. As in previous examples, we can only access pgdatabase 1 through Confluence 1. So, in order to connect to the SSH server on pgdatabase 1, we must pivot through Confluence 1. We'll compromise Confluence 1 by exploiting CVE 2022-26134 with our reverse shell payload, and create an SSH remote port forward to relay a port on our Kali machine to the SSH service on pgdatabase 1. We'll then SSH into pgdatabase 1 as the database admin user. Since Feline Authority is also on the WAN, we can SSH directly into Feline Authority using the username Kali and the corresponding password. We now have two open shells. The first is on pgdatabase 1 as the database admin user, and the second is on Feline Authority as the Kali user. In order to simulate a real DNS setup, we can make Feline Authority a functional DNS server using DNS Mask. DNS Mask is DNS server software that requires minimal configuration. A few DNS Mask configuration files are stored in the DNS tunneling folder, which we'll use as part of our DNS experiments. For this initial experiment, we'll use the very sparse dnsmask.conf configuration file. This configuration ignores the etcresolve.conf and etchosts files and only defines the auth zone and auth server variables. These tell DNS Mask to act as the authoritative name server for the feline.corp zone. We have not configured any records so far. Requests for anything on the feline.corp domain will return failure responses. Now that the configuration is set, we'll start the DNS Mask process with the dnsmask.conf configuration file, making sure it runs in no daemon mode so it runs in the foreground. We can kill it easily again later. In another shell on Feline Authority, we'll set up TCP dump to listen on the ENS192 interface for DNS packets on UDP 53 using the capture filter UDP port 53. Now that TCP dump is listening and DNS Mask is running on Feline Authority, we'll move to our shell on PG Database 1. From here, we will make DNS queries aimed at the feline.corp domain. First, let's confirm PG Database 1's DNS settings. Since DNS resolution is handled by systemd resolved, we can check the DNS settings using the resolvectl utility. PG Database 1's DNS server is set to 10.4.50.64, which is multi-server 3. It will query multi-server 3 anytime it needs a domain name resolved. But PG Database 1 has no outgoing network connectivity, so it can't communicate directly with Feline Authority or our Kali machine. As an experiment, let's use NSLOOKUP to make a DNS request for exfiltratedData.feline.com. This returns an NX domain response that indicates the DNS request failed. This is expected though, as we haven't configured our DNS server to actually serve any records. The TCP dump program on Feline Authority captured DNS packets from multi-server 3. In this case, we've received a DNS A record request for exfiltratedData.feline.corp on Feline Authority. This happened because multi-server 3 determined the authoritative name server for the feline.corp zone. All requests for any subdomain of feline.corp will be forwarded to Feline Authority. We didn't tell DNS Mask on Feline Authority what to do with requests for exfiltratedData.feline.corp, so DNS Mask just returned an NX domain response. We can see this flow in the following diagram. The steps where multi-server 3 sent queries to the root name servers and TLD name server have been omitted here for simplicity. But in a normal network situation, these steps would precede the request made to Feline Authority. An arbitrary DNS query from an internal host with no other outbound connectivity has found its way to an external server we control. This may seem subtle, but it illustrates that we can transfer small amounts of information, exfiltrated data, from inside the network to the outside without a direct connection, just by making DNS queries. Now that we have covered the process of exfiltrating data from a network, let's consider how we might infiltrate data into a network. The DNS specification includes various records. We've been making A record requests so far. An A record response contains an IPv4 address for the requested domain name. But there are other kinds of records, some of which we can use to smuggle arbitrary data into a network. One of these is the TXT record. The TXT record is designed to be general purpose and contains arbitrary string information. We can serve TXT records from Feline Authority using DNS mask. First, we'll kill our previous DNS mask process with Ctrl-C. Then, we'll check the contents of dnsmask.txt.conf and run dnsmask again with this new configuration. The dnsmask.txt.conf contains 2 extra lines starting with txt record. Each of these lines represents a TXT record that dnsmask will serve. Each contains the domain the TXT record is for, then an arbitrary string attribute separated by a comma. From these 2 definitions, any TXT record requests for feline.corp should return the strings "here's something useful" and "here's something else less useful." Let's test this hypothesis. Back on PG Database 1, we'll make a request for TXT records for feline.corp with NSLOOKUP by passing the -type equals txt argument. Success! We retrieved the arbitrary string attributes that were defined in dnsconfig.txt.conf. This is one way to get data into an internal network using DNS records. If we wanted to infiltrate binary data, we could serve it as a series of base64 or ASCII hex-encoded TXT records, and convert that back into binary on the internal server. In this section, we discussed how we might infiltrate or exfiltrate data through various types of DNS records. In the next section, we'll get some hands-on experience with the DNSCAT2 framework, which leverages these techniques to create a multi-purpose DNS tunnel.